Let's begin. We are group 5. We are going to talk about Th2 cells. The human body has a function called immunity that kills foreign substances such as bacteria when they enter the body. The ultimate goal is to have neutrophils eat the bacteria.
When bacteria enter the body, first antigen-presenting cells such as macrophages, dendritic cells, and B cells take in some of the bacteria, break them down, and head for the lymph nodes. Then, they tell T cells in the lymph nodes what kind of bacteria has entered the body. This is called antigen presentation. Through antigen presentation and other actions, naive T cells grow into effector T cells. There are several types of effector T cells, including helper T cells, regulatory T cells, and cytotoxic T cells. And Th2 cells is a type of T helper cell. Upon antigen presentation, T helper cells cause B cells to grow into plasma cells. B cells have an antibody called IgM, while plasma cells produce an antibody called IgG that is more effective against bacteria. This is called class switching. The binding of IgG to antigens on the surface of bacteria makes it much easier for neutrophils to eat the bacteria. This is called opsonization. So far, we have seen a series of immune responses to bacteria.
Here is a closer look at Th2 cells. It reacts primarily to the antigen presentation of bacteria, parasites, and allergens, such as mites, moles, and pollen. In order for naive T cells to develop into effector T cells, co-stimulation, which involves the binding of structures called co-stimulatory molecules to each other, and the production of signaling molecules called cytokines from antigen presentation cells are required, in addition to antigen presentation. The type of cytokine determines which type of effector T cells naive T cells will differentiate. Among naive T cells, CD4 positive naive T cells, which have the molecule CD4 differentiate into Th2 cells under the cytokine IL-4 and into Th1 cells under IL-12 or IFN gamma.
Both Th2 cells and Th1 cells are called helper T cells, and the role of them is to produce cytokines and enhance the function of immune cells. Th2 cells primarily make cytokines such as IL-4, IL-5, IL-9, and IL-13. These can induce IgM-bearing B cells to differentiate into plasma cells and proliferate them. However, this class switching by Th2 cytokine biases the plasma cells toward producing IgE, an antibody that causes type 1 allergic reactions. It is desirable to have the plasma cells produce IgG rather than IgE, so this is where Th1 cells are useful. Th1 cells produce IFN gamma, a cytokine that activates the IgM to IgG class switching. In summary, the differentiation of B cells into IgG-producing plasma cells require cytokines from both Th1 and Th2 cells. In this way, plasma cells differentiated from B cells and opsonize bacteria with IgG and phagocytosis by neutrophils proceeds.
This is the summary of Th2 cells. Type 1 allergy is a kind of disease caused by Th2 cell activity. It causes an unnecessary and abnormal immune response to things that are not as harmful to the body as bacteria and viruses such as mites and pollen. At this time, Th2 cells are more active than Th1 cells, resulting in the production of large amounts of IgE, which in turn causes allergic symptoms such as hay fever, asthma. That's all. Thank you for listening.